Ever imagined Earth with not just one, but two moons? It might sound like the plot of a sci-fi movie, but this fascinating phenomenon is becoming a reality for a brief moment in time. For the next 2 months, our planet will welcome a new, temporary moon, a cosmic visitor scientifically known as a mini-moon. These rare occurrences captivate astronomers and space enthusiasts alike, offering a chance to witness something extraordinary. But what exactly is a mini-moon, and how does it find itself orbiting Earth? Unlike our permanent moon, which has been a constant companion for billions of years, these mini-moons are small space objects, typically asteroids, temporarily captured by Earth's gravity. Their visit is fleeting, lasting only a few months before they are slingshotted back into space. This celestial event offers scientists a unique opportunity to study near-Earth objects, NEOs, and how our planet interacts with them. You might be wondering if this mini-moon will be visible or if it will affect anything here on Earth. While it won't disrupt tides or weather, its presence sparks intriguing questions about how objects move through space and what opportunities these temporary satellites offer for future research. Stay tuned as we dive deep into the science, explore how mini-moons behave, and uncover why astronomers are so excited about this rare event. What is a mini-moon? A mini-moon is a small celestial body temporarily captured by Earth's gravity. Unlike our permanent moon, which has been orbiting Earth for billions of years, mini-moons are typically asteroids or fragments of space debris that wander too close to our planet. These objects get caught in Earth's gravitational pull and remain in orbit for a short time, usually a few months, before continuing their journey through space. The key difference between our moon and a mini-moon lies in size, lifespan, and orbital behavior. While the moon has a diameter of 3,474 kilometers, a typical mini-moon is only a few meters wide. Their smaller mass makes them more susceptible to disruptions by other gravitational forces, meaning they don't stay for long. Earth's gravity creates a temporary bond with these objects, but the sun's gravitational influence eventually pulls them away, releasing them back into space. A famous example is 2020 CD3, a mini-moon about 3.3 meters in diameter. It was discovered in February 2020 by astronomers using the Catalina Sky Survey in Arizona. Although it orbited Earth for about a year, it eventually escaped our gravitational grasp. What made 2020 CD3 special was how hard it was to detect. Most mini-moons are so small and fast-moving that they evade even the most advanced telescopes. Scientists categorize mini-moons as quasi-satellites, a term used to describe objects that share similar orbital paths with a planet but don't remain in orbit for long. These small visitors are exciting for astronomers because they represent natural space laboratories. Unlike distant asteroids or comets, mini-moons come close enough to Earth to offer insight into near-Earth objects, NEOs, and their composition. Interestingly, these mini-moons also present opportunities for future space missions. Some experts suggest that mini-moons could become ideal targets for asteroid exploration or mining. Their proximity and temporary capture make them accessible and relatively easy to study with current technology. With each new mini-moon discovery, scientists gain deeper insights into the complex gravitational dance between Earth, the Moon, and the objects that wander close to our orbit. The science behind mini-moons. So, how does a mini-moon get captured by Earth's gravitational pull, and what makes it stay in orbit temporarily? The answer lies in the delicate balance of gravitational forces in our solar system. When an asteroid or space object drifts close to Earth, its speed, size, and trajectory determine whether it will pass by, collide with Earth, or be caught in our gravitational field. If the object's speed aligns just right with Earth's orbit, it becomes a temporary satellite, a mini-moon. Mini-moons usually orbit Earth in irregular and unpredictable patterns. Their path around our planet is influenced by the gravitational tug-of-war between Earth, the Moon, and the Sun. This means that their orbits tend to wobble, shift, and vary in speed. Eventually, most mini-moons escape Earth's gravity, either flung back into deep space or drawn into a closer encounter with the Sun. According to NASA, Earth is likely to capture a mini-moon once every 10 to 20 years, though most of these objects are so small that they go undetected. A concept crucial to understanding mini-moons is the Hill sphere, the region around a planet where its gravitational force dominates over the Sun's. Earth's Hill sphere extends about 1.5 million kilometers from the planet's surface. Any object within this sphere can be influenced by Earth's gravity and potentially captured. However, most objects within this region are moving too quickly or follow trajectories that only allow them to swing by briefly. Another interesting aspect is the role of Lagrange points, specific positions in space where gravitational forces between Earth and the Sun balance out. These points sometimes act as way stations, where small objects can remain relatively stable for a while before drifting away again. While most mini-moons don't sit at these points, they do pass through similar gravitational conditions, influencing their brief stay in Earth's orbit. There is also growing interest in using mini-moons as test subjects for space missions. Their proximity and short-term presence make them accessible targets for missions aimed at exploring asteroids or testing new space technologies. For example, NASA's Artemis program and ESA's Hera mission are both working on asteroid-related technologies that could benefit from mini-moon research. Although mini-moons don't affect tides, weather, or Earth's rotation, they offer invaluable research opportunities. Understanding how Earth interacts with these wandering objects could help astronomers predict similar events in the future, including potential threats from larger near-Earth objects. Moreover, the study of mini-moons could play a crucial role in planetary defense strategies, such as asteroid deflection missions aimed at protecting Earth from future impacts. Each time we encounter a mini-moon, it provides astronomers with a rare chance to analyze how small objects behave in Earth's orbit, information that might one day help us understand or even prevent cosmic disasters. Tracking the current mini-moon, the newest mini-moon to join Earth's orbit, has already captured the attention of astronomers around the world. It was first spotted by the Pan-STARRS Observatory in Hawaii, a leading facility for tracking near-Earth objects. This mini-moon, estimated to be 2 to 3 meters in diameter, is comparable in size to a compact car, making it challenging to detect without powerful telescopes. Its small size means it reflects very little light, requiring advanced optical systems to spot it in the vast darkness of space. What makes this mini-moon especially intriguing is the estimated 2-month duration of its orbit around Earth. While most mini-moons remain undetected until after they leave, this one offers a rare chance for astronomers to observe it in real time. During its brief stay, scientists are eager to track its orbital movements and gather as much data as possible about its composition and behavior. The object is believed to be a fragment of an asteroid or space debris that was nudged toward Earth's orbit. However, its precise origins remain unknown, an exciting mystery for astronomers to solve. It could potentially be a natural fragment from the asteroid belt between Mars and Jupiter, or even a leftover remnant of a space mission. The ability to pinpoint its origins will help scientists better understand how space debris behaves and evolves in Earth's vicinity. Due to the mini-moon's small size, it likely won't be visible to the naked eye. However, observatories around the globe are planning to track it using telescopes, with some institutions offering public live streams of the event. If weather conditions and visibility are favorable, astronomers might even publish observation windows for hobbyists with telescopes to catch a glimpse. Tracking these temporary moons is no small task. Astronomers must account for multiple variables, including changes in speed, angle of orbit, and external gravitational influences. This new mini-moon's path is expected to shift slightly during its 2-month stay, influenced by interactions with Earth's gravitational pull and the presence of the Moon. After completing a few orbits, it will eventually escape Earth's gravity, likely drifting back into solar orbit. This 2-month window offers a golden opportunity for researchers to study the mini-moon's trajectory and physical properties, contributing valuable data to the growing field of asteroid science. Controversial insights and potential risks. Whenever a new mini-moon or near-Earth object is discovered, it often sparks both excitement and concern. Although most mini-moons pose no threat to Earth, the idea of an unknown object entering our orbit raises questions about our ability to detect and monitor space debris effectively. There are ongoing debates among scientists and space agencies regarding whether our current tracking systems are sufficient to predict and manage such encounters in the future. One controversial insight is the risk of undetected objects entering Earth's orbit. Most mini-moons are too small to be spotted early, as they reflect little sunlight and often travel at high speeds. This has fueled concerns about planetary defense systems. Are we prepared to identify and deflect potentially hazardous objects before they get too close? The discovery of this mini-moon serves as a reminder that, despite technological advances, many objects in space remain undetected until they are right upon us. Another interesting angle involves the potential risks associated with space debris. Some experts caution that mini-moons could interfere with satellites or space missions if their paths were to overlap. However, since most mini-moons follow irregular orbits far from the crowded regions where satellites operate, the likelihood of a collision remains extremely low. Beyond safety concerns, there's also debate about exploiting mini-moons for mining or exploration purposes. Some space experts suggest that these objects could serve as targets for asteroid mining missions, providing a sustainable way to gather raw materials like metals and minerals. However, this idea has raised ethical questions about the commercialization of space and whether we should tamper with natural celestial bodies for human benefit. Should space exploration prioritize scientific discovery, or is it acceptable to view objects like mini-moons as future economic resources? While mini-moons are fascinating from a scientific perspective, their presence highlights the limitations of current space surveillance technologies. Detecting these temporary satellites after they enter Earth's orbit shows that there's still much to be done to improve global tracking systems and early warning mechanisms. Despite the low risk posed by these small objects, they remind us how unpredictable space can be, and why continuous investment in planetary defense and space exploration is essential. This temporary mini-moon may be harmless, but the questions it raises about space monitoring, future exploration, and planetary defense will linger long after it has drifted back into the depths of space. Future of mini-moon research. The arrival of this temporary mini-moon has reignited interest in the study of near-Earth objects, NEOs, and the valuable insights they provide. For astronomers, every mini-moon is an opportunity to refine models of how asteroids behave when they interact with Earth's gravitational pull. These observations also play a key role in planetary defense planning, giving scientists a chance to improve techniques for tracking space objects that could pose a future threat. One area of focus is the development of better space surveillance technologies. Current systems like Pan-STARRS and NASA's NEO Surveyor mission aim to detect asteroids and space debris well before they come close to Earth. However, as mini-moons have shown, small objects are notoriously difficult to detect until they're already in orbit. Future advancements in telescope technology and AI-based tracking algorithms could improve detection rates, providing scientists with more lead time to study these objects. There is also interest in using mini-moons as practice targets for future space missions. Both NASA and the European Space Agency, ESA, are planning asteroid exploration missions, such as NASA's Artemis program and ESA's HERA mission, which will focus on the behavior and composition of small celestial bodies. Mini-moons could act as testing grounds for technologies designed to deflect or capture asteroids, offering insights that might one day be used to protect Earth from a potentially dangerous object. Another emerging concept is asteroid mining. As mini-moons are relatively easy to reach, they represent a potential opportunity for space mining operations. Some experts believe that in the future, we could harvest valuable resources such as rare metals from these small objects. This idea aligns with the long-term vision of creating sustainable space exploration industries, but it also raises important questions about the ethics of exploiting celestial bodies. For now, mini-moons remain a scientific curiosity, but they could play a far more significant role in the coming decades. Whether through planetary defense strategies, space mining, or technological innovations, these temporary moons offer a glimpse into the future of space exploration. Each new discovery builds on what we know, helping us better understand how our planet interacts with the dynamic, ever-changing environment of space. With each mini-moon that crosses our path, astronomers edge closer to answering critical questions about Earth's gravitational influence and the nature of near-Earth objects. This research could help predict future encounters with both harmless and potentially hazardous space objects, further solidifying humanity's readiness for whatever the cosmos throws our way. Public engagement and telescope events. The excitement surrounding this new mini-moon isn't just for scientists. Space enthusiasts and the general public have a rare opportunity to engage with this event. Many observatories and research institutions are planning public outreach programs, including live streams of the mini-moon's journey across the sky. These events will give people around the world a chance to witness Earth's temporary second moon from the comfort of their homes. Some telescopes may even allow viewers to participate remotely, controlling camera angles to get a closer look at this cosmic visitor. Organizations like NASA, the European Space Agency, ESA, and independent observatories are already preparing to release observation schedules. If weather conditions permit, individuals with access to powerful amateur telescopes might also be able to see the mini-moon for themselves. This is a fantastic way for astronomy clubs, schools, and curious individuals to learn more about mini-moons and near-Earth objects in real time. Social media channels will also play a key role in tracking the event. Platforms like Twitter, Facebook, and Instagram are expected to share updates from space agencies and observatories, including alerts for key observation windows. Following these updates ensures enthusiasts don't miss any critical moments. For those interested in tracking the mini-moon themselves, several skywatching apps can provide real-time coordinates and movement updates. Apps like SkyGuide, Stellarium, and Skyview make it easy to follow celestial objects, offering step-by-step instructions for finding them in the night sky. This rare mini-moon event isn't just a passing curiosity, it's an incredible opportunity for public engagement with astronomy. By participating in these events, people can better understand the dynamics of Earth's orbit and the fascinating world of near-Earth objects. So, mark your calendars, grab a telescope or tune into a live stream, and get ready to witness a cosmic event that only comes around once in a while. As this temporary mini-moon orbits Earth for the next 2 months, it offers both a fascinating spectacle and an exciting scientific opportunity. These rare celestial visitors remind us of the complex interactions between our planet and the universe beyond. Although this mini-moon won't impact tides or weather, its presence highlights just how dynamic and unpredictable space can be. Every encounter with a mini-moon brings new insights that help scientists refine their understanding of near-Earth objects and Earth's gravitational influence. From improving planetary defense strategies to advancing asteroid mining technologies, this brief event holds significant implications for the future of space exploration. For researchers, mini-moons act as valuable practice targets, providing essential data on how small celestial bodies behave when caught in Earth's gravitational web. As tracking technologies continue to evolve, astronomers hope to detect mini-moons earlier and use them as stepping stones toward larger missions. But beyond the scientific excitement, this mini-moon offers a moment for the public to reconnect with the wonders of space. Whether through live-streamed telescope events or using apps to track the object from home, people around the world have the chance to witness a cosmic event that only a few get to experience. It's moments like these that reignite our curiosity about the universe and remind us how much there is left to discover. So, as the mini-moon gracefully completes its fleeting dance around Earth, it leaves us with a deeper appreciation for the mysteries of the cosmos. Who knows what other celestial surprises await us in the years to come? With every discovery, we are reminded that space is a vast, unpredictable frontier, and our understanding of it is just beginning to unfold. If you enjoyed learning about this rare phenomenon, don't forget to like, share, and subscribe to our channel for more cosmic updates and space explorations. Stay tuned as we continue to explore the universe, because you never know what's just around the cosmic corner.